We'll compare the strengths of electric and gravitational forces between two protons. Here's the problem. Compare the strengths of the electric and gravitational forces between two protons. Given Coulomb's constant K equals 8.99 times 10 to the ninth, gravitational constant G equals 6.67 times 10 to the negative 11th, charge of a proton Q equals 1.6 times 10 to the negative 19th coulombs, and mass of a proton M equals 1.67 times 10 to the negative 27 kilograms. Determine the ratio of electric force to gravitational force and comment on what it shows. First, note that both forces follow an inverse square law, so the separation distance r cancels out. The ratio of electric force to gravitational force equals kq squared over r squared divided by gm squared over r squared, which simplifies to kq squared over gm squared. Now calculate the numerator. K times q squared. Kq squared equals 8.99 times 10 to the ninth times 1.6 times 10 to the negative 19th squared. That's 8.99 times 10 to the ninth times 2.56 times 10 to the negative 38th, which gives 2.30 times 10 to the negative 28th. Next, calculate the denominator. G times m squared. Gm squared equals 6.67 times 10 to the negative 11th times 1.67 times 10 to the negative 27th squared. That's 6.67 times 10 to the negative 11th times 2.79 times 10 to the negative 54th, which gives 1.86 times 10 to the negative 64th. Now compute the ratio. The ratio is 2.30 times 10 to the negative 28th divided by 1.86 times 10 to the negative 64th, which is approximately 1.2 times 10 to the 36th. Interpretation: the electric force is about 10 to the 36 times stronger than gravity between two protons. Gravity is negligible at the particle scale. The key takeaway is that the electric force is vastly stronger than gravity at the subatomic scale, by a factor of about 10 to the 36th.